Now, there are four issues with regression you need to be concerned with overall. The first one I'm going to talk about is extrapolation here. So with extrapolation, the idea behind extrapolation is we're going to predict far outside the range of reasonable inputs. So for example, okay, if we're talking about, given an equation is relationship between age and weight of a puppy, okay, and we said predict the weight of a 8-year-old dog, okay, that would be an issue with extrapolation, okay? First of all, if we're talking about a puppy, we'd probably want to keep everything to maybe 0 to 12 months or however long the stage is for a puppy. By the time you're 8 years old, that's going to be, well, let's see, 8 times 12 is 96. If I actually plug into my calculator 3.8 plus 0.6 times 96, that means that the puppy went ahead and became, at 8 years old, 61 pounds, which may be reasonable, but we should know that eventually a dog gets to their ideal weight between like 1 or 2 years. So that would be an example of extrapolation. We should not do this. It is far outside a range of reasonable inputs. We're doing this for a puppy. So it probably stays to a pretty good line in the beginning, but eventually it tapers off and levels off at some point in its early age. So that's an example of extrapolation. Next up, let's talk about outliers. Outliers are going to be extreme values here overall in certain directions. Now, visually, this will help out overall. Remember, we're dealing with two quantitative variables, and the visual here is called a scatter plot. A scatter plot is used to depict the relationship between two quantitative variables. So here, everything looks pretty nice overall, okay? And let's say we had a point right here. This would be considered an outlier, which has a large residual, because there's a far versus its maybe predicted line. We would say there's a very big gap between the actual y and the predicted y. So an outlier would have what's considered a large residual overall. And then you have something called an influential outlier, which is going to be a large gap in the x and the y direction, maybe something out here. This would be considered what's known as an influential outlier. And what I mean is it's far away in both directions. So it's not along the clump of data in the y, and it's far off in the x direction as well. So something that's really not following the path overall can actually change the slope significantly, and in some cases could change the slope from maybe a positive to a negative or a negative to a positive, and that's an extreme case. So you have to worry about outliers, that points that are far away from the least squares regression line. And that was the second one we need to discuss here. Correlation does not mean causation. Just because two things are correlated does not mean one causes the other. Did you know that when ice cream sales, so when ice cream sales increase, I was thinking of increase first, shark attacks increase? It's the most common one to explain. Gee, so when ice cream sales go up, shark attacks go up. I've literally looked up news articles where they're a day off, where one news article will say ice cream sales are on the rise, and the next day shark attacks are on the rise. Do ice cream sales cause shark attacks? And the answer is no. If they did, stop buying ice cream. The reason why is because temperature, when it increases, more people tend to buy ice cream. Notice how I said tend to, or expect to. When it's warmer outside, more people go to the beach. Sharks may get a little bit closer to shore. It's not a big issue, but it is still something that's present. And that's one example of where correlation does not imply or mean causation. Lastly, Simpsons paradox. This one is fun. I've actually seen this once in real life with real data. Basically, looking at the whole data, the whole picture of data shows one relationship, but subsets will show a different, okay? So basically, a visual on, again, a scatter plot. Maybe if you're looking at a scatter plot, and again, if you watch me draw this, you're going to see the subsets first of all. So maybe this is dealing with some set of data, and looking from left to right, there looks like an overall positive trend. But what if this happens to be maybe one company, another company, another company, another company, another company? Putting them together looks positive, but looking at them separately looks negative, and that's what's called Simpsons paradox, where the whole picture of data shows one relationship, but the subsets show a vastly different relationship. So you need to make sure you're aware of what the definitions are for these issues with regression. Again, extrapolation, predicting far outside, above, or below a reasonable range of data. Outliers or influential outliers are extreme points far away from the clump of data. Just because two things are correlated does not mean one causes the other. And Simpson's paradox is where one interpretation shows one relationship, but looking at individual parts of it might show a different.